Okay, in the previous class, we have discussed about what is constructor and what is constructor overloading. Okay, so what is constructor and what is the use of constructor and what is constructor overloading, you have seen, right? So in today's class, we will see the use of this keyword. Okay? So before going to discuss about this keyword, so let us see one example. So last class we have seen this example, so box demo. So this is the program we have seen in the previous class. So now the purpose of this program is to calculate the volume of a box, right? So here we have three instance variables. So double height and width and depth. There are three instance variables here. Okay? So and we have one constructor. Three instance variables and one constructor we have here. So the constructor role is to initialize the instance variables. Okay, to initialize the instance variables, right? So now here the constructor takes three different arguments. One is H, W, and T. So now the constructor parameterizer constructor in a how it takes three parameters 5, 6, 7. Now 5, 6, 7 are assigned to H, W, and T. Now these values are in turn assigned to instance variables height, width, and depth. Okay, height, width, and depth are the instance variables. Now it returns height star, width star, depth. Okay, so this is how the program works in the earlier class you have seen. So when you run this code, when you compile this, so box demo dot Java and then Java box demo. Now it returns the result to 10. Okay. It returns the result to 10. So for example, here I want to use both the instance variables and the local variables, both are same. Now this is in place of W, again use width. In place of depth, use in place of D, use depth. Okay. So now here what happened is, this is actually left hand side instance variable, right hand side local variable. Okay. So our interpretation is this left hand side height represents instance variable and right hand side height represents this local variable or the parameter. Okay, similarly width also same. This width represents this instance variable and this width represents parameter. Similarly, this depth left hand side depth represents instance variable and right hand side depth represents this local variable. Okay. So now let us compile the code and see what happens. Now when you compile this, so there is no problem. But when you run the code, what happened is it returns the volume is 0.0. Volume is 0.0. So what happened here? What is the problem with this code is when you use both the instance variable and the local variable or the parameter name same, then automatically what happened is the instance variable is hidden by the local variable. That is, whatever the local variables are there here, and that is here the local variable are the parameters passed as arguments to the constructor. This height and this width and this depth hides the instance variables. Okay. Hides the instance variable, that this height and this width and this depth. Okay. So that here inside the constructor, this height, width, and depth. Okay. These variables are treated as local to this constructor. So that these instance variables never initialized. So that is the reason why you got 0.0. Okay, that is volume is 0.0. Now we have to avoid this problem. You need to avoid this problem. Now, how to avoid this? Now there is a solution for this problem, that is using constructor, using this keyword. Okay, this we can eliminate by using the keyword this. Okay, so what is the purpose of this keyword is, so sometimes what happened is, sometimes the method will need to refer, sometimes the method will need to refer to the object that invoked it. Okay. So sometimes what happened is, a method will need to refer to the object that invoked it. Now, in order to achieve this, to allow this, Java provides the keyword this. Java provides this keyword. Okay. So now to allow this, Java provides this keyword. So that is, this keyword is used to refer the current object. Okay. The keyword this is used to refer the current object. Current object means that is the object on which the method was invoked. Okay. Current object refers to the object on which the method was invoked. So, for example, in our example, in this case, we have a class, that is a box class is there, and creating object for box. Okay. Box B. Now, when you use the keyword this always refers to the current object. What is the current object? Here, box class object B is there. Now, this always reference to the current object, that is box, in our example. So, this always a reference to the object on which the method was invoked. Okay. This always, the keyword this always a reference. This always a reference to the object on which the method was invoked. Okay. On which the method was invoked. For example, here, that is our class here. Box class is there, and box object is there here. Okay. So now when you write b dot volume, okay, b dot volume, suppose. Now volume method is invoked on which object? This box class object. So that whatever the variables used inside this method, height, width, and depth, are belongs to the current object only. Okay. So that if you want to use this particular object, so the object always, the keyword always a reference to the object on which the method was invoked. So this is the general purpose of this this keyword. Okay. So now this is generally used whenever the instance variable is hiding, suppose. Okay. So the general case is generally what you have to, where this keyword is used is whenever these type of situations are rising. Okay. That is instance variables are hiding, suppose. Okay, so that is whenever instance variable ID. Okay, there you go for this keyword. Okay, so then use the keyword this. Okay. So whenever there is a case where the instance variables are hiding, so then use the keyword this keyword. Okay, so that is instance variable when this situation arises. Suppose if we use instance variable, comma, local variable or parameters. Name, that is if you use same name for one is the instance variables, this is the first one, local variable or parameters. Local variable or parameters. Same name if you use. So in this case, what happened is, so this results. So then, so these variables hides automatically hides the instance variables. These variables hides the instance variables. Now in such case, you have to go for the keyword this. Okay, this is the main advantage. In general, this refers to the current object. So, but whenever there is a case where the instance variable is hidden, okay, from these local variables are the parameters of the methods. Okay, local variables are the parameters. Parameters of the methods are the parameters of the constructors. Okay, so in such case, what you have to do is use the keyword this. So, for example, earlier I told there is a class, so box class is there. So now in this class we have a variable depth. Suppose there is a variable depth is there. Okay, and I am writing box class again. So inside this class, I want to use, so for naming convention, I want to use same variable as argument. Then what you have to do is use the keyword this. This dot depth is equal to depth. That's it. Okay. This dot depth is equal to depth. Now this refers to current object. So this is a reference to the current object. So that what happened is when you write like this, so now this, so this dot depth. Now this represents instance variable. Here the depth represents instance variable. Okay, this dot depth represents instance variable, and this right hand side depth represents parameter. This is the parameter. So like this, you can avoid the conflicts between these instance variables and the local variables using the keyword this. Okay. So this is the advantage of the keyword this. So in the case where you need to refer a method need to refer the object on which it was invoked. So in such case, use the keyword this. Okay, that is this keyword is always a reference to the current object. This one. Okay, so now this always a reference to the object on which the method was invoked. Okay, so this is the case. So where the keyword this is useful is when the instance variable is hiding, suppose by the local variables or the parameters. Okay, in such case, what you have to do is use the keyword this. Okay, this is the purpose of the keyword this. Now let us modify the code in the program, this one. Now to avoid this problem, earlier what we got is the volume is 0.0. So because the instance variables here height, width and depth are hidden, so that it never initialized. So its default values are 0.0, so that you got 0.0 star, 0.0 star, 0.0. So we got 0.0 because it is a double variable. Now to eliminate this problem, what you have to do is use the keyword this dot height equal to height, and this dot width equal to width, and this dot depth equal to depth. No? So then we got compile the code Java C and Java. Now we got to 210. Now the result is 210. Okay. So because this is 5 into 6, that is 30, 30 into 7, that is 210. So we got 210 as the answer. Okay. So this is the modified or the revised version of the program. This one. Okay. So please make a note of this. So this is regarding the use of this keyword. Okay. So next, let us go to the next concept. So another small concept. So garbage collection. What is meant by this? Garbage collection, we see. Garbage collection. Okay. So now if you observe our Java programs, so in our program, this is the object we have created. Okay. For example, this is B1. Okay. So on B1, what we did is so create an object B1, then invoke method volume, that is 3, 2, 5, suppose. Okay. Then again invoke the volume method on B2 also. Okay. Here how many objects are there? Here 2 objects are there. Now these 2 objects, when you compile the code, you got this volume is 210 and the volume is 30 here. Okay. So because we have 2 different objects here, B1 and B2. Okay. And this B1 and B2 points, B1 and B2. So this is generally creates, this is B1 object, this is B2 object here. Okay. Now this B1, B2, this is B1 and this is B2. B1 and B2 consists of, this is height and this is width and this is depth. This is height, this is width, this is depth. Okay. So now here it is going to create memory for these 3 different variables because it is a double variable. Okay. Because it is a double variable, it is going to create memory for these 3 variables. This is height, width, and depth. This memory for these 3 double variables will be created by B1, and memory for these 3 double variables will be created. Okay. So here B1 and B2 two objects are there. Now for both, so memory will be allotted. Okay. Memory will be allocated for both B1 and B2. Okay, now once the program completes its execution, now once the program terminates, now whatever the memory allotted for this B1 and B2 remains there in the memory. Okay, so now because this is created by using the new operator. Okay, now we are not at all deleting this memory. in the program. Okay. So, but if you consider C and C++, so in order to create memory, dynamic memory in C, we have a function called malloc, and it will be deleted using the free function. Okay. And similarly, if it is a C++, we can use new operator and use delete operator. Okay, there is an operator called delete in C++. Okay, this is the C++ case and this is the C case. So if it is a C, malloc and calloc and use free function, and if it is a C++, new and delete operators are there. But in the case of Java, just you are creating memory for the objects, but you are not at all deleting. Now, who is going to delete this? So now there is a concept called garbage collection. There is a concept known as the garbage collection. So now it is used to delete the memory which was occupied by the objects. Okay. Now how this garbage collection works, let us see. Okay. So how this garbage collection will works, that's what we have to see, right? So now nothing is there. So when no reference to an existing object, when there is no reference to an existing object, when there is no reference, so there is no reference to an object. So when no reference to an object exists, okay, so then that object is assumed to be, so that object is assumed to be no longer needed, and the memory occupied by the object can be reclaimed. Okay. So when there exist, when there are no references, so when there is no reference, so for example, when there is no reference to an object exists. So for example, here we have created object for class box B1, and another object box B2 is equal to new box. So now here B1 and B2 are no longer referenced, suppose. There is no reference to these existing objects B1 and B2. Now this object is assumed to be no longer needed. If there is no reference, means this is not at all required. So then whatever the memory occupied by these particular objects B1 and B2, okay, either 8 bytes or 16 bytes or 24 bytes, whatever it may be, okay, occupied by these particular objects B1 and B2 can be reclaimed. So that is, it will be taken back and it will be added to the pool of available memory or some other new object. Okay. So now this particular process will be done sporadically in Java. Okay, this will be happened sporadically. So that means occasionally this process will continue by the Java Virtual Machine JVM. Okay, JVM will take care of this particular process. Okay, so this mechanism is known as the garbage collection. Garbage means that is unused objects here. Whatever the unused objects are there inside the memory, Okay, whatever this P1, whatever this P2 or P3, if there are no references made to this particular objects, there are no references made, so automatically you have to delete this. Okay, who is going to delete this? Our Java virtual machine will take care about this. Okay, this particular mechanism is known as garbage collection. Okay, so now to understand more about this, so let us see one example. So this is a simple program. So there is a method called this finalize method. So the object is garbage collected here. So we have two objects. JVM, that is system.gc. Now this is going to perform garbage collection internally. Okay, this is going to perform garbage collections. So for example, if you want to see this Java C gcdemo.java, so this will raise an warning gcdemo. So the object is garbage collected and object is garbage collected because we have two different objects. Now each time the system.gc is invoked, it will invokes first this finalize method. Okay, this finalize method will be called. So then garbage collection will be performed. So that we cannot see. So this object one is garbage collected, object two is garbage collected. Okay. So this is what exactly known as the mechanism of garbage collection. Okay. So next, this is regarding the keyword. This concept of garbage collection. Okay. Now next we'll move on to the this session inheritance. Next we'll move on to the concept of inheritance. So this is one of the striking feature of object-oriented programming. Okay. So this is one of the important feature of object-oriented programming. We know the basic concepts of object-oriented programming. So like class and object and encapsulation, dynamic binding, polymorphism, abstraction, inheritance, message passing. Okay, we know all these basic concepts of OOP. So now one of the striking feature of object-oriented programming is the inheritance. Okay, so now we'll see what is meant by inheritance. Okay, and what are the different forms of inheritance. Okay, now how to implement the concept of inheritance in Java. Okay, so now inheritance is one of the basic concept of OOP. Okay, so this is one of the basic and important concept of object-oriented programming. Okay, so now the term, what is the meaning of this inheritance? So generally, this inheritance so refers to inheritance refers to the reusability of existing class. Okay, so inheritance generally refers to the reusability of the existing class. So that is what we have to do is, so we can create a new class. Okay, we can create a a new class from the existing class. Okay, and the new class consists of both the members of new class consists of both the members. That is, it consists of its own members as well as the existing class members. Okay, so it is generally it is a form of so parent and child relationship. Okay, it is a form of parent-child relationship. Okay, so that is we can create a new one. So that is whenever you are creating a new class, existing class is there now. That is the existing class is known as uh, parent class, or sometimes it is also known as the super class, or also called the base class. Okay, so existing class is known as the parent class, or another name is the super class or the base class. Okay. So, and when you're creating a new one, the new class is there now. So the new class is called, it is a child class, or another name is the subclass or derived class. Okay. So now this child class or the subclass or derived class includes its own members as well as the members inherited from the parent class. Okay. So that is the child class. Okay. That is the child class will have all the members of the parent class, but the parent cannot access the members of the child class. So this is what exactly the concept of the inheritance. Okay. So for example, if you want to see, so this is one class, this is another class, and this is another class. Okay. So for example, this is the let us take this is the class known as person. Okay, this is the class called person. Now the person may be a student or he may be an employee. Okay, person may be a student or employee. Now here the person will have, here the object will have different members as you are aware. Okay, some variables are there, some methods are there. Okay, so for example, here, so if you consider this person, person will have different attributes like this. For example, this is, so he has one attribute called name, maybe a string. Okay. Name may be a string, and some methods like here, one method set name, one method will be there. Okay. So and similarly here the student will have some attributes like class, student number, it's maybe integer, and you can also write some methods. Suppose a set number, one method will be there, and here employee will have some EMP ID. Okay, so EMP ID may be an integer type, and here an employee, some method will be there. Suppose uh, set ID, there is a method called set ID. Okay, now here both the student and employee are derived from the class person. Okay. So where the class person is acts as a parent class. The class person will act as a parent class or base class. This one is the parent or base class. And the student and employee are the child classes. These two are the child classes. Okay. This is called the concept of inheritance. Okay. This is called the concept of inheritance. That is, the student acquires the properties of person, that is name, and similarly employee acquires the properties of this person called name. Moreover, this employee is a person and student is a person. So that both the classes acquires the properties of the existing class, that is person. Okay. So this is what exactly known as the concept of the inheritance, in which there are two classes are there. One is the parent class and another one is the child class. Now we need to establish a relationship between the parent and the child. That is here the parent class is the generalization here. Okay, it is generalized. Now anybody can extend this particular class, acquire its properties. Moreover, this student and employee are the specific classes. Student is a specific class, employee is a specific class, but person is a generalized class. This one. Okay. Now, in a parent-child relationship, this parent provides generalization, and the child provides the specialization. It is a specific, okay, specific class acquires the properties of its parent class. Okay. So this is called, this is the definition of this inheritance. So this is the illustration of the concept of the inheritance. Okay. So now let us see what are different types of inheritance in Java. Okay. Types of inheritance in Java. Right. So now let us come back to this. So types of inheritance. Okay. Types of inheritance. Now coming to these types of inheritance, first one is the single inheritance. Second one is the multi-level inheritance. Okay. Third one is the hierarchical inheritance. And the fourth one is the multiple inheritance. Okay. Fourth one is the multiple inheritance. Okay. These are the different forms of inheritance. Okay. So one is the single inheritance. All right. One is the single inheritance. Single inheritance means a class can extend only one parent. Okay. So that is one parent class and one child class. So that is known as the single inheritance. Okay. And next one is the multi-level inheritance, means a class is derived from another derived class. Okay. That means you can derive a new class from another derived class. So that is known as multi-level inheritance. Okay. So we'll see the illustrations. So first we need to see the definitions of this. Okay. So what is single and what is multi-level inheritance? Okay. And next one is the hierarchical inheritance. So now, so deriving so multiple classes from a single parent class. Okay. This is called the hierarchical inheritance. Okay. That means you can derive a class, okay, from the parent. That is, the parent may have multiple child classes. Okay. So deriving multiple child classes and write child classes from a single parent class. Okay. So this is called hierarchical inheritance. So next one is the multiple inheritance. So this you cannot achieve directly using class concept in Java. Okay. So deriving a child from multiple parent classes. Okay. So now this cannot be achieved directly using classes. Okay. So in Java, this multiple inheritance you cannot implement using the concept of class. Okay. So there is a concept called interfaces. Using interfaces, you can implement this. Okay. So this is called multiple inheritance. Okay. Single inheritance, multi-level inheritance, and hierarchical inheritance. Okay. And multiple inheritance. Okay. So single means one base class, one derived class will be there. And multi-level means so deriving a class from another derived class, that is A to B and B to C and C to D like that. And hierarchical means one parent class will be there and multiple derived classes are there. Okay. So deriving multiple childs from the same parent class. Okay. So and multiple means multiple child classes are there, parent classes are there, and one child class will be there. Okay. So this you cannot implement directly in Java, right? So now if you want to see this, so this is the illustration. Different forms. Right. So these are the different forms of inheritance. Right. So this is single inheritance. This is the single inheritance. That is one superclass and one subclass. And next, this is the multi-level inheritance. This is the multi-level inheritance. This is a superclass, and then next subclass, and the next subclass. Okay. For example, A is the superclass, and then derive B. Okay. Now this B is derived from A, and then C is derived from B. This is called the multi-level inheritance. Next one is the hierarchical inheritance. This hierarchical means one superclass will be there, and then two subclasses. Okay, one superclass and two different subclasses. Suppose if A is the superclass, then B is one subclass and C is another subclass. Both B and C acquires the properties of A. So this is called the hierarchical inheritance. And next one is the multiple inheritance. Using classes, you cannot achieve this. So, but there is a concept called interfaces. Okay, interface one, interface two. These are acts as the superclasses for this. Okay, these are acts as superclasses. So this is what we will see later. Okay. So now let us see the implementation of this inheritance concept. Okay. Implementation of the inheritance concept. Now, how to implement this? So please make a note of these forms of inheritance. Okay. Now, so how to implement this inheritance, right? Now let us come back to this part. Now implementation of inheritance. Right? Implementation of inheritance. Now to implement inheritance, so Java provides a keyword called extends. Java provides a keyword known as extends. Okay. So there is a keyword called extends, right? This keyword is used to implement the concept of the inheritance. Okay. So now, so it can be used as follows. For example, class. This is the new class. Use the keyword extends old class. Okay. Extends old class. Here you can write body. Okay. Class, new class. So where new class is the child class here. Where new class is the child class. Now class, new class extends to old class. Right? This is the general form. Okay. So R. Sometimes you can also use R. Right? Now class. This is a new class. Extends to old class. Implements interface 1, interface 2, and so on. Interface N. Okay, this is also acceptable. Okay, then here you can write body. Okay, then you can write body. Okay, so this is the general form of using the keyword extends. Okay, so both are valid, right? So here class, new class extends old class. So this is the simple inheritance. We are implementing a simple inheritance concept. Okay, so because only one class you can extend, multiple classes you cannot extend. Okay, so Java provides only simple inheritance. That is only one class you can extend. Multiple classes you cannot extend. Okay. Now another way is class, new class extends old class and implements multiple interfaces. But okay, so you cannot extend multiple classes. Okay, you cannot extend multiple classes, but you can implement multiple interfaces. Okay, the class can implement multiple interfaces. So implements interface 1, interface 2, interface 3, and so on. Now this is useful for implementing multiple inheritance. Okay, this syntax is used for implementing multiple inheritance. This is used for implementing multiple inheritance concept. Okay? So, for example, if you want to write example, suppose class C, class B extends A, class B extends A. So, if class A is the existing one, then use the keyword extends to acquire the properties of A into B. Okay. So, and similarly, this is a class, suppose class B extends A, implements, suppose interface C So C is one interface, D is one interface, and E is another interface. Okay. So this one, right? Now in this example, class B, this is the B, is the derived class. Class B acts as a derived class. A acts as a parent class, this one. And C and D and E are the interfaces. These are also acts as the superiors to this B. So now this gives a form of multiple inheritance. Okay, this gives a form of multiple inheritance. Okay. So now this general form is used for implementing multiple inheritance. Okay. So now this is the syntax to implement the concept of inheritance. Okay. So there is a keyword called extends. Now the keyword extends is used to implement or extend the new class. Okay, create a new class and that class acquires the properties of the existing class. Okay, so now let us see the implementation of forms of the inheritance. Okay, implementation of the forms of inheritance. Right. Now first let us go for the single inheritance. The first one is the single inheritance. Okay, single inheritance. So what is this single inheritance? Single inheritance means one base class and one derived class. One base class and one derived class. That is known as the single inheritance. Okay. For example, this is one base class and this is one derived class. Okay. So let it have some data members and methods, and this is also having some data members and methods. So for example, this is class A. Okay. Suppose this is class B. B is the derived class. Okay. B is the derived class. Now B acquires the properties of this base class. Okay. Suppose let us take some variables here. So integer I comma j, integer I comma j. Two variables are there here, and integer k is another variable here. Okay. So here one method is there. Show ij. There is a method called show ij, and this is sum. Another method called sum will be there. Okay. So when you apply the concept of inheritance, so now these variables. So these both I and j. So now you can access I and j and show ij. Okay. Show ij from class B. Now when you extend the class B, okay, when you extend class B, now B will have the members of class A as well as B also. That is ij available from B and show ij method is also available from B. Okay, so this is the simple concept of single inheritance. Okay, one base class and the one derived class. Okay. So this is the concept called single inheritance. So now the illustration of this code part we will see in the next class. Okay. So this is what we have discussed in today's class. Okay. So finally, so in the today's class, what we have covered is, so what is the first one? So today's topics covered. So first one is the, so this keyword. What is the purpose of this keyword? And the next one is the garbage collection, and third one is the introduction to inheritance. Introduction to inheritance. So this is what we have covered in today's class. Okay. So first one is the use of this keyword. So what is the purpose of this keyword? So this keyword is always a reference to the current object. Okay. This is always a reference to the current object. That is the object on which the method was invoked. That is represented by the keyword this, but most widely used in the case of instance variable hiding. Okay, the keyword this is used in case of instance variable hiding. So instance variable hiding means, so if the instance variable name is same as the local variable or the arguments of the constructor of the method, then the instance variables are hidden by the local variables. So in such case, what you have to do is use the keyword this keyword. Use the keyword this. Okay, that is the purpose of this keyword. Next one is the garbage collection. So garbage collection means you automatic deletion or reallocation of the unused objects. Okay, whatever the unused objects are there in a program, so which are sporadically collected, and the memory occupied by those objects will be reclaimed. Okay, so that is if there exists no reference, there are no references made to an existing objects. Okay, so and those objects will be marked as unused objects, and the memory occupied by those objects will be reclaimed. Okay, that is the concept of garbage collection. The next one is the introduction to inheritance. So what is inheritance? Inheritance is reusability of the existing ones. Okay, that is reusability of the existing class. Okay, so that means we can create a new class, and the new class acquires the properties of the existing class, and the new class will have both the members of its own as well as the existing class. Okay, so that is the concept of inheritance. And what are different forms of inheritance? Single inheritance and multi-level inheritance and hierarchical inheritance and multiple inheritance. Okay. So in case of single inheritance, so there is one base class and one derived class. And multi-level means you can create a derived class from another derived class. And hierarchical, so there only one base class will be there and multiple derived classes are there. Okay. So, and multiple inheritance, multiple base classes are there, but you cannot implement using the concept of class, but you can go for the inheritance interfaces to implement the multiple inheritance. Multiple inheritance. Okay. Now, how to implement inheritance? There is a keyword known as the extends keyword. Using extends keyword, so we can implement the inheritance concept. Okay. So in the next class, we will see what are the different types of inheritance and its code implementations. Okay. So thank you all.